Hey, welcome. This is a linear algebra in Python with SciPy step-by-step tutorial. Today is the first day of this linear algebra tutorial, and in this tutorial, I will cover how to implement vector operations with Python. Basically, vectors are one-dimensional arrays that represent quantities with magnitude and direction. So SciPy, along with NumPy, provides various functions to perform vector operations. In this tutorial, I will demonstrate two fundamental uh, vector operations, which are the dot product. The dot product, also known as the scalar product of the two vector measures the similarity between the two vectors, and it returns a scalar value and defined as the sum of the element-wise products of the two vectors. And the second one I am going to implement is cross product. The cross product known as the vector product as specified to three-dimensional vectors. It is not like a product, I mean, a dot product, but it's just known as a vector product, basically specific to three-dimensional vectors, and it returns a vector that is perpendicular to both input vectors, and the cross product is used in geometry and physics to calculate the normal vector of a plane or to compute turquoise in mechanics. Let's try to see the mathematical explanation of this, the two vector operations. Let's consider two vectors, vector 1 and vector 2. Vector 1 is 1, 2, 3, and vector 2 is 4, 5, 6. And I will perform the following operations to perform the vector operations. The first one is dot product. As I have said previously, the dot product is known as a scalar product or a scalar vector of two vectors that measures the similarity between vector 1 and vector 2. And the result could be the scalar value and defined as the sum of element-wise products of the two vectors. So just multiply the elements of each vectors, and the result would be the sum of the products of each element in the vectors. So this is the mathematical notations of dot product in vector operations. V1 index 0 multiply V2 index 0. For example, 1 multiplied by 1, I mean 4 plus 2 multiplied by 5 plus 3 multiplied by 6. This is called element-wise products, the sum of element-wise products, and the result could be a scalar value, one value only. And the cross product is different from the dot product, but the cross product is also known as a vector product, and this cross product basically is specific to three-dimensional vectors, and the result is perpendicular to both input products or input vectors. So this vector 1 and vector 2 are the cross product is given by vector 1 multiplied by vector 2 minus vector 1 multiplied and so on. And that is a copy a one-dimensional array. Okay, this is mathematically a representation, and I will implement this using Python, and you can easily demonstrate the vector products using Python. Okay, first of all, you have to import NumPy library. This is the most powerful library for numerical computation. Okay, and then the next, let's define the two vectors, vector 1 and vector 2. Vector 1 is, let's say, 1, 2, 3. 4, 5, 5, 6. Okay, now let's find, sorry, there should be comma in each element in the vectors. Now let's find the dot products of the vector 1 and vector 2. To do this, NumPy supports the dot product function, dot product, and we can just use v1 and v2, and the result could be a scalar values. Let's run this product. That is 32 because 1 multiplied by 4 plus, that is 4, plus 2 multiplied by 5 is 10, 10 plus 4 is 14, plus 3 multiplied by 6 is 18, 18 plus 14 is 32. This is called a scalar value. So the result of the dot product in linear algebra or vector operation is called the scalar values. Okay, how to implement the cross products, and the cross product is different from dot product because the result of the cross product is a one-dimensional array. It is specific to three-dimensional array in the cross product, and let's do this using NumPy. NP dots, there is a function that NumPy supports is called cross, and let's pass v1 and v2 as an argument to this function. Let's find the cross product of the two vectors. Okay, so the result of the cross product of the two vectors are a one-dimensional array because cross product basically is specific to three-dimensional array. The inputs are two-dimensional array, and the result or the output is one-dimensional array in the cross product. So this is the simplest way. So you can do this using Python without any challenging, because if you are not good in math, but Python can help you to improve your mathematical skills. Okay, and don't forget to like, share, and subscribe, and follow the next day tutorials about linear algebra with SciPy, step-by-step tutorials. And thanks for watching.